Chapter 2, we're gonna look at lines, angles, triangles, quadrilaterals, and circles. All sorts of exciting stuff. In particular, today, 2.1, we're gonna do lines and angles, and 2.2, we're gonna look at triangles. So, definition: when a ray is rotated about its endpoint, an angle is created. So think about starting here. This is called the endpoint. We rotate like so. We draw the ray, and we get what's known as an angle. So an angle is really the amount of rotation that you get from the to where the ray started to from where the ray started to where the ray ended. And if we do one complete rotation, that's called 360 degrees. And then there are some famous angle names. There's a right angle, that's a 90-degree angle. Straight angle, 180 degrees. Acute is between 0 and 90, and obtuse is between 90 and 180. So you'll hear me use those words occasionally. Some other famous words you'll hear: complementary angles. Those are two angles that add up to 90 degrees, like 50 plus 40. And supplementary angles. They're two angles that make a straight angle add up to 180 degrees. Okay, then there are some famous theorems you might remember from geometry if you took that in high school. So, when two lines intersect to form equal angles on opposite sides of the point of intersection, these angles are called vertical angles. So in other words, if you draw two lines, angle C and angle D will always have the same measure, and angle A and angle B will have the same measure. Those are called vertical angles. And then you have a transversal line. That's a fancy word. Crossing two parallel lines. Well, all that means is you have two parallel lines, and then you have another line going across. Then we get lots of pairs of equal angles. 1 and 4 are equal because they're vertical angles from above, but also 1 and 5 are equal. Those are called corresponding angles. And then 4 and 5 are also equal. These are known as alternate interior angles. And then you would have 1 and 8 would be alternate exterior angles. So you get lots and lots of things being equal here. So you get 1 equals 5, 3 and 7, 2 and 6, on and on and on. You can see all those pairs. We'll use this occasionally. Alright, now let's talk about triangles. I'm sure you know what a triangle is. A triangle, of course, has 3 sides. And there are different names for different kinds of triangles. There's a scalene. Scalene has 3 sides where none of them are the same. Isosceles triangle has 2 equal sides, which also forces 2 equal angles. That angle and that angle would have the same measure. Equilateral triangle, all 3 sides have the same measure, which will force all 3 angles to have the same measure. And then you have a right triangle. This is probably the most important one. We will talk about right triangles a lot in this class. They have a right angle. And so these 2 sides are called the legs. That one's called the hypotenuse. And an important fact, the sum of the angles in a triangle is always 180 degrees. So if you add up the 3 angles, you'll always get 180 degrees. Alright, so let's take a look at what we have here. In the figure below, AB is parallel to CD. Find all the angles. And it gave us a couple. This one's 28. This one's 41. So right away, I would know that angle 3 is also 41. That's a pair of vertical angles. Now, when we write our degree measure, make sure you put that degree symbol there. You really need that. This is 41 degrees. It's not just 41, it's 41 degrees. All right. Then angle 2 and this 41 degree angle, those are supplementary because that makes a straight angle. So angle 2 has to be 180 degrees minus 41 degrees. I might grab my calculator. 180 minus 41 is 139 degrees. Once I know angle 2 is 139 degrees, I also know angle 4 is 139 degrees, because once again those are vertical angles. Next, I think I can get angle 1, because I can use this triangle, angle 1, angle 2, and 28 degrees, and it has to add up to 180. So angle 1 has to be 180 degrees minus 28 degrees minus 139 degrees. Let's see, calculator says 180 minus 28 minus 139. Angle 1 is 13 degrees, which means angle 5 also has to be 13 degrees. We've got our alternate interior angles there. And finally, angle 6 has to be 28 degrees. Again, alternate interior angles. All right, so you can see where we use some of those theorems in a problem like that. All right, well, here's probably the most famous theorem about triangles. Something that students forget about this theorem is it has to be a right triangle. It doesn't work in any triangle. It has to be a right triangle. In any right triangle, the sum of the squares of the two legs are equal to the square of the hypotenuse. Well, nobody ever remembers it that way. Everybody always remembers a squared plus b squared is c squared, where a and b are the two legs, and it doesn't matter which one is which, but c always has to be the hypotenuse. C is always the longest side. It's the one opposite the right angle. A and B can be interchanged. They're not as important. C is the important one. All right. Use the Pythagorean theorem to find the unknown side of each triangle. Assume all measurements are exact. Well, that's convenient because then we don't have to worry about rounding off significant digits, all that stuff. All right, so this would be side C. This is the hypotenuse that we don't know. So 6 squared plus 8 squared would have to equal c squared, which means 36 plus 64 is c squared. 36 plus 64 is 100. And then we would take the square root, and we would find c is 10 meters. All right, now the second problem, now of course we're assuming these are right triangles. They didn't draw that in. I'm going to draw it in, because if it's not a right triangle, it doesn't work. In this one, we know c because we know the hypotenuse. So what I call this one really doesn't matter. Again, I could call it a or b. I'm going to call it a. So I would have a squared plus 3.50 squared equals 7.25 squared. So a squared is, I'm going to grab my calculator, I'm going to do 7.25 squared, and then I would subtract this to the other side, so minus 3.50 squared is 40.3125. Take the square root. A is the square root of that answer. And both these numbers were told to be exact, but they only gave us 3 significant digits, so it would still make sense to only give 3 significant digits here. So I'm going to call that 6.35 inches. Okay. A house is 24 feet wide, and the ridge is 9 feet higher than the sidewalls. If the roof rafters are to be extended 1.5 feet beyond the sides of the house, how long do the rafters need to be? All right, so you might not know much about houses and rafters and stuff. Let me draw a quick picture here. You can see my fabulous artistic skills. So what they're talking about here is this house is 24 feet wide, and the ridge is 9 feet higher. So they're telling you that is 9. And they're telling you that these have to extend 1 feet beyond the side of the house. So this distance here is 1.5 feet. What it wants to know is, what does this total distance have to be? So I think what we got to do is we got to consider this triangle. Like so, and find the length of the hypotenuse. Notice this side will only be 12 feet. So I think we're going to have, I'll call this C. C squared equals 9 squared plus 12 squared. So C squared is 81 plus 144. So 81 plus 144. And then I take the square root. I get 15. Of course, that's not the final answer, because that just gives that distance. It doesn't give the extra 1.5. So my final answer is that the rafters have to be 16.5 feet long. All right, the last thing we have in this section is perimeter versus area. Perimeter is distance around, so perimeter would be add all the sides, where area is the amount of space inside the figure. Area is how much is inside. To find perimeter of a triangle, we add the 3 sides. To find area, there's a formula. This is a formula you should know. Area is 1/2 base height, where base is the length of one of the sides, and the height is the perpendicular from the opposite angle back down to that side. All right. So, find the area and perimeter of the following triangle. Round your answer to 3 significant digits. I can find the area already. Area is 1/2 times the base times the height. So I grab my calculator. 0.5 times 6.82 times 3.55, and that would be round to 3 significant digits, 12.1. And units here would be square feet. Area is always in square units, because really what we're doing is saying how many little squares can we put inside here. Now, to find the perimeter, I've got to find the length of that side, so I've got to use my Pythagorean theorem. So C squared is 3.55 squared plus 6.82 squared. Grabbing my calculator. So I get that, and then I take the square root. So I'm going to say C is 7.69. Because it said to round to 3 significant digits, so it makes sense to only give 3 significant digits there. So my answer is 7.69 plus 3.55 plus 6.82. Calculator says 18.1 feet, rounding to 3 significant digits. All right, last problem, very, very similar. I may run out of time. I'm going to try to go fast. This time we need to find this length. I'll call this B. So B squared plus 3.55 squared is 7.55 squared. So grabbing my calculator, 7.55 squared minus 3.55 squared, and then do the square root. Hit the right buttons, there we go. B is 6.66. Alright, so my area is going to be 1/2 times 6.66 times 3.55, and you'll grab your calculator, type that in, that's in square centimeters, and the perimeter is going to be 6.66 plus 3.55 plus 7.55, and that answer will be in centimeters. Okay, so grab your calculator, do those calculations, round them off to 3 significant digits.